Today's experiment is the conductance of solutions. The purpose of today's experiment is to study the conductivity of different substances. Conductivity is a material's ability to conduct an electric current. This current is measured in microsiemens per centimeter. For today's procedure, you will be using a program called MicroLab. Step 1 is the calibration. Use the conductivity of 0.02 molar potassium chloride in air to calibrate the conductivity probe. So first we're going to open the program called MicroLab and click on OK. We want to add a sensor since we have to measure the current, so click on Add Sensor. Go to the drop-down menu of Sensor and select Current. Then we have to choose an input, so you can just select the first one, and that's labeled Current A. Click on Next. Then you want to perform a new calibration, so click on that. And you want to add the points of the calibration, so click on Add Calibration Point. The red line in the middle is going to let you know when the probe is stabilized at the actual value of 0. Now we're going to calibrate the probe in the 0.02 molar potassium chloride solution. This is a given table of the conductivity of potassium chloride at different temperatures. If we look at the thermometer, it reads 18 degrees Celsius. Using the table, we know that at 18 degrees Celsius, the conductivity of potassium chloride is 2,397 microsiemens per centimeter. This is how you would use the table to determine the conductivity. This is the probe placed in a beaker of DI water. We're going to get a chem wipe and wipe down the probe and blot out any excess water. Then place the probe into a test tube that has the potassium chloride solution. Make sure that the actual value box has the value 2,397 and allow the red line to stabilize, then click OK. Now you can see the new calibration point on the graph. Now we are going to wash the probe. Remove the probe from the solution and use DI water to wash the probe. Place a beaker underneath so the water falls into it. Use a chem wipe to wipe down the probe and blot out any excess water. Now we will calibrate the probe in the air. Click on Add Calibration Point. Make sure the actual value in the box is 0. Allow the red line to stabilize, then click on OK. Now you have a new calibration point. Make sure the graph is in first order, which is linear. Accept and save this calibration. The units are microsiemens per centimeter. Then click on OK. Save the calibration under the T drive in the Calibrations folder. Save the calibration as the date then click Finish. Now you're going to drag the sensor to the digital display. Now you can read the current. It is normal for the current to fluctuate. You will now determine the conductance of different solutions. These solutions include sodium chloride, hydrochloric acid, sodium hydroxide, copper sulfate, ammonia, acetic acid, methanol, sugar, DI water, and tap water. You will then determine the electrolyte type and bonding type. If the conductance is greater than or equal to 1,000 microsiemens per centimeter, then the electrotype is strong. If the conductance is greater than or equal to 200 microsiemens per centimeter, but less than 1,000 microsiemens per centimeter, then the electrolyte type is weak. If the conductance is less than 200 microsiemens per centimeter, then the electrolyte type is none. You will then determine the bonding type. An ionic bond donates an electron to the other atom participating in the bond. Electrons in a covalent bond are shared equally between the atoms. The measurement of the current on the digital display will jump around. Record the integer number that you feel most confident in. Since the range of conductance is very large, recording a varied measurement does not have a significant effect on the data. First, you will use sodium chloride. Remember to record only the integer number when measuring the current. Also, wash the probe after each solution. Next is hydrochloric acid. Next is sodium hydroxide. Next is copper sulfate. Next is ammonia aqueous or ammonium hydroxide. Next is acetic acid. Next is methanol. Next is sucrose. Next is DI water. Lastly, you will use tap water.